Hey guys, this is Miss McCann coming back at you with another lecture. Hopefully by the time you guys see this lecture, all of my issues on wisdom will be resolved and I will be able to get things more streamlined and information will be easier to understand and assignments will be easier to find. We are figuring this out as we go, so this is a rough, bumpy week. I understand some things are wacky, so just go with it. Hopefully it gets better, and let's jump into the lecture. So this year we're going to do a paper and a year-long study on some wave heights and buoys, which we will get into tomorrow. But first you kind of need to be familiar with graphs and types of graphs and what you would use those graphs for, because you're not just going to hand someone a raw data table and expect them to know what you're talking about. Raw data tables don't make any sense to anybody but you. So you need to be able to make graphs and charts to make your points easier to understand in a shorter amount of time and be able to get your point across faster. So you first have line graphs, and that's data that changes over time or variable. So you have an independent variable and a dependent variable. Typically your dependent variable is going to be put on the y-axis and your independent variable is going to be put on the x-axis. So if you're measuring something over a given amount of time, your independent variable is going to be time, and your dependent variable is going to be what you are measuring. Now on this next slide, it's going to tell you that it's going to flip it around and say your dependent is going to be on the x and your independent is going to be on the y. You could flip it, but it's not going to make much sense unless you just have a negative trend in data. You're always going to have a data table that looks like this, where if y'all guys have taken a math class, this kind of looks familiar, and you're going to have a line that does this, and this is going to be your x-axis, and this is going to be your y-axis, and this is your trend line. These should be things that are familiar from math. So this is a line graph. You can see that time is increasing as temperature is increasing. So you've got a positive trend line, and it shows the relationship between two variables, your independent variable and your dependent variable. So this is another line graph. This is probably closer to what your line graph is going to look like when we build one tomorrow. And you're going to have this in a Google Sheets document. So you're going to build a table like this with your X and your Y column and make a table. I'm going to make a video and walk you through that tomorrow. So other types of graphs, you've got bar graphs and pie charts. We will more than likely never use a pie chart in here. Pie charts are really only used for surveys where you take a poll. Bar graphs are kind of the same way. They compare data for several items or events. We really aren't going to focus on that in here. I don't foresee us really using a bar graph. So this is what a bar graph looks like. Y'all should have done this in elementary school in math class. This is another bar graph. So you've got different types of metal and their melting temperature. This is a pie graph. So pie graphs are done in percents, and all the percents have to equal 100. So you've got another pie graph here. So presenting scientific data continued. Why is organizing data an important science skill? Because scientists use written reports and oral presentations to share their results. Organizing and presenting data are important science skills. This is something we will learn this year. We'll cover it. We'll hit it many times. So this is an example of a raw data chart that this person's having their class do. I'm not going to have y'all guys do this. You just need to email me one thing that you learned from this assignment, or comment it down below. You'll probably comment it down below. So there are some questions. They're asking for a line graph. So this is a bar graph. Plant height, amount of fertilizer. You see that they've got different types. So then here's another one. So key ideas. Why is organizing data on an important science skill? So that you can clearly and concisely, in a reasonable amount of time, communicate your results from an experiment and get your point across. How do scientists handle very large and very small numbers? You plug them into a computer and let the computer handle it. And how can you tell the precision of measurement? Typically, the more decimal places you have, the more precise your number is. And we are done for the day. Make sure to comment below, and I will see you guys in the next lecture tomorrow. Have a great day.